Hi, my name is Matt, and I'm a rising senior at Crystal Springs. Today I completed my second milestone, which was essentially to finish the base project, and this involved programming the phone controller with App Inventor and then writing and editing the Arduino code to include this phone output. And when I was testing everything to confirm that the phone app properly controls the arm, I initially ran into a lot of issues. The first of which was that the servos were very jittery and sometimes wouldn't even run, even when prompted to. And I immediately knew this had to be a problem with either the Bluetooth or the code. And because when I had just run basic code to the servos through Arduino without using the phone controller, then everything had worked properly. So I knew it couldn't be an issue with the wiring of the servos or their positioning. So I printed the Bluetooth outputs from the phone to the Arduino onto the monitor, and I found that they were mostly all incorrect and not what App Inventor was telling me the phone should be printing or should be sending to the Arduino. So I identified that the problem was the Bluetooth connection, and after doing some research, I found that the baud rate I had set my HC6 Bluetooth module to was incorrect and didn't match the baud rate of my phone. And the baud rate is essentially the speed that the data transfers over Bluetooth, and it needs to match because otherwise the device will be sending data at a different speed than what the Arduino is, or whatever the receiver is expecting it to, and this causes a lot of data corruption. So after I set the baud rates to be equal, then it was much easier to identify other problems, as this cleared up a lot of the Bluetooth issues. So I also had issues with the reset button on the phone controller, and essentially when the Arduino is first plugged in, I have the arm default to a position where all the servos are near the middle of their range of motion, and I wanted to create a button on the controller that someone could press to just put the arm back to this default position, as it's I think it's a very useful way to just restart whatever motion you're trying to do or whatever position you're trying to get the arm into. But at the start, then this wasn't working very well, and only the base would actually reset to the default position, and sometimes it would even reset to a different position. And after I again started printing the Bluetooth outputs to the monitor on the laptop at key points in the Arduino code, and I realized that the phone was sending all the outputs as one command to the Arduino. So basically, instead of telling the Arduino's base to go to default, then the claw, then the elbow, then the wrist, and all the servers to go to default separately, it was sending the code to send all of them to default in one command. So basically trying to make the Arduino do all the commands at the same time, which is impossible. And so I realized I had to implement a delay function on App Inventor so that the Arduino could refresh the Bluetooth input identification between the times when the commands were being sent, and that would allow it to interpret these commands as separate, and it would then be able to control each of the servers separately. And then there were also a few typos in my Arduino code which I had to fix. For example, I had to fix my speed function, which basically would just change the delay of the servo adjustments, and this was because I didn't realize at first that the delay function was only could use integer type data, and the speed was originally a double, so I had to change the slider outputs for my phone controller and make them compatible with this data type by basically just increasing them and then dividing them into integers. So I'm now finished with the base project, and my next step is to start working on modifications. My first modification will probably be building and implementing a car that will go under the base, which I think will be very helpful and allow the arm to move around more.